Hey, Evan Reese here. We're picking back up from the previous video where we talked about value with units and some of the math functions available within input fields in Onshape features. In this video, we're going to cover some different ways of manipulating numbers and rounding them and things like that. So let's get to it. You ever run into a situation like this when you have a certain number of holes and they need to go a certain length and then they need to stop? And you might have this thing changing lengths all over the place. You might have it configured and you want to make sure that the number of holes is always right. This one right now is just hard coded in here. There's my count. And you can see I have a bunch of extra ones and I don't want any holes that are partial on the end of this thing. So I want to make sure I stop before the end. So how might we accomplish this? Well, we can use some of the techniques we're learning on how to navigate the fields inside of Onshape. So we're going to need a few bits of information. One is we need the length of this whole thing. And I could either drive the length by inputting it as a variable and dimension here, but I actually, for this example, I'm just going to keep this sketch free and loose, and we'll have it update live. So in order to get this value, I'm just going to click that edge. There we go. Wasn't showing up for a second. And set this to total length. So now this is a measured variable, and if I change the sketch, this number will change as well. And then for the cell length, I have a different sketch that I used to drive that. Okay, cell length is there. And now we need a count value. So I'm going to use a variable again. The count needs to be a number, not a length. And it's going to be called count. So what we really want is total length divided by cell length. But I can't use that as a number in my pattern because it will fail. You can't have real numbers. It needs to be an integer. It needs to be rounded. So if I put that in there, it will say enter a valid expression. So that doesn't work. What we need to do is round this. And there's functions for that. So I can type round, parentheses. I'm hitting command and left and right, and that'll kind of jump to the very next empty space. So I can go all the way to the left side, all the way to the right side. A handy shortcut. So now that I've got that rounded, it's going to take us to the closest number. And I can go and put this in as the count. Cool. And that's looking good in this case. Let's try it out and see how it looks in other cases. So far, so good. Uh-oh. Okay, we still have a partial hole here. So we need to add a little bit more logic to how this thing's working. Maybe we don't want to round up ever. We only ever want to round down. So to do that, we can use the floor function instead. And that means that it's only ever going to round down. And if for some reason you wanted to only ever round up, you can use the ceiling function, ceil. There you go. And that's going to always, I must have auto-completed something bad. Get rid of that. I'm not going to hit enter because that will autocomplete. I'm just going to click somewhere. And now we're always going to have one too many instances. So not what we're going for in this case. I do want to point out something interesting though. When I type any of those functions, like floor, you can see we're actually getting autocomplete coming up for two different things. This is what's called overloading in FeatureScript and other coding languages. So these are both functions. You give it some arguments. That's the name of the X or the unit here. Those are arguments. And so you give it a certain set of arguments and it spits out some result. That's the basics of a function. And in this case, there are two different functions that are declared in FeatureScript that both have the same name. And that's what's referred to as overloading. So if I have floor of, let's say, 5 point blah, 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 it's always going to round down, even if this is above the middle there. So if this was a round function, that would go up. But because it's floor, it goes down. But you saw that that other one had the ability to add a unit. And what I can do with that is make it round to the nearest 10. So nearest like multiple of 10. So 0 is closer. But if I go 15, or let's say that I went 5, then it's going to round down to 5. It's closer to 0 than it is to, well, it's a floor function. Let's change it to a round function. There we go. So that has the same thing. So yeah, it's closer to 6 than it is to 0. It's going to round up to 10 because it's just a little closer to 10, but not to 11, or I guess it is to 11, 12. Eventually, yeah, there we go. It drops back to 0 because that's actually closer to 0 than it is to 12. So you can You can add units that way. And it's just worth noting that as you start to type stuff, you get these other things popping up. So you can see some examples of the kinds of units you might see. But also there's other functions that you can take a look at. Round to precision is a good example. So if I have my other, random number that needs to be rounded, round to precision, actually the second argument is how many decimal places we want. So I can just put 3 and it's going to lop off all the other decimal points and just round to whatever precision I want here. I find this pretty handy if I'm trying to put a value into a string that I'm going to use to name a part or assign some metadata to the part. I don't need to have 8 decimal places. So this is how I would lop those off. I want to talk about some other functions that help you make sure that you are getting the correct number. So let me go back to this extrusion example from the previous video. I'll get rid of those. I'll get rid of that. Let's imagine that this is a piece of off-the-shelf hex bar stock, and we want to guarantee that it's always going to be shorter than whatever we can buy. Let's say it comes in 8-foot lengths. So we can never buy one longer than 8 feet. I don't want anyone to model one longer than 8 feet. So I'm going to say the max is going to be 8 feet. And that's a new variable that I just created. And now we can also put target length. I use the word target to signify to me that that's the goal, but that may not be the result that I get. So my target length is going to be 6 feet. I'll put that above here as well. Inside the extrude feature, we can use the min function, and it's needing 2 arguments. I'm going to hit enter to complete with the autocomplete, and I'll say max. That's this variable that I just created. And I will say target length. I'm just typing TL, and because I've used camel case here, I capitalized that first letter of the second word, it autocompletes really well. So TL enter is all I need to type. And I'll drag this out so that you can see it better. So now what's happening is our bar stock is 6 feet because we are able to make it 6 feet. That's fine. But if the target length goes above the maximum value, I'm actually going to go ahead and make a variable called length that just contains that same information. So min of the max or target length. That'll just make it easier for you to see when it changes. So if I edit the target length, check final so you can watch this thing grow, and you can look at this number here to see what this is, like the actual length, whatever the length is going to be. I can type in like 7.9 feet just so we're already really close. And then if I keep going up here, you notice that eventually the length number stops going up because we exceeded the max length available. So I cannot make this bar any longer than 8 feet because of the way that I've used that function. Now we could also do a minimum if we wanted as well. Let's say that it doesn't make any sense to have anything less than 1 inch. All right, so now this can be, we're going to make sure that if it's less than the max, it'll give us whatever this value is. But now we want to check if it's more than the minimum. So I'm going to type, or I want to make sure we return more than the minimum. So when I type max, I get 2 options because I've named a variable max, but I'm going to make sure I use the function. So basically this is saying like, if it's less, or if it's more than the max, give us the max value. But if it's less than the max, then do whatever this function is. And that's going to be, I'm going to put the min value. That's my variable. This is kind of confusing because I've used the exact name. So sorry about that. And then I'm going to use the target length. So in this case, I cannot also go, if my target length is 0.5 inches, this should return, just 1 inch there. And this is a contrived example to show you how you can, stack these things or nest them inside of each other. In reality, to accomplish this task, you can actually just use a function called clamp. So I can put in my target length and min and max, and that does the same exact thing. So it's a little more concise, but I just wanted to show that nesting first. Another situation you might run into is if you're dealing with like negative numbers and you don't want them to be possible to be negative. So let's call this 10 millimeters. And this is going to be length. I should have set that to equal just length earlier to get the behavior that I was describing, but that would work. Okay, so what I can do here is actually use an absolute function. Let me show you first what happens if I don't. So if I check final and I go down and down and down, this thing actually reverses direction. And I don't want that to be possible, let's say, in this example. So I can use a function called absolute, which is ABS. There we go. So now that was inside of the extrude feature. So now if I change this to be -70, it's not going to change the output at all. And as I go up and head towards 0, you'll see that it just goes back up again. So it's always returning a positive value inside of here with the absolute function. All right, that's it for rounding and this video. See you in the next one where we're going to dig into even more complicated stuff. We're going to dig into some Boolean logic, true false statements, if-then statements, and some other incredible ways that you can imbue your models with more design rules and logic. See you there.